Right. We are live with about 25 minutes until day 10 of Advent Code 2024. Um, and to start off tonight, I think I'll go back through some of my to-dos for little helpers to implement and spruce up my little mini standard library here. So I believe there was one in day 9 somewhere. Okay, an interval.shift. So the idea here is to be able to move an interval left or right by some amount. Okay, let's do that. Let's make this full screen. And we will also test things as we go. So here's my interval class. It's an interval over some integral type, usually int, or usually int. And it's got these helpers, yada yada. These are the most useful ones. The ability, this is the reason I have interval and I don't use the built-in range, is because I want this intersect, diff, and union methods. Let's see. Def shift. So n int. No, I think that can be an n, whatever our integral type is. And we do another interval. And this will be this copy min equals this dot min plus n. And ditto for max. Okay. So let's use that here in day 9. Shift. Great. So now instead of doing an interval.copy, our new position is interval.shift. I don't like that name interval. We should give it something more specific. By this distance. Okay, that should still work. Let's make sure that's still correct. I feel like I saw it change. Ooh, yeah. Okay. 24.9. Let's undo some changes real quick. This will be what the new code is. But I'm not sure that's the implementation we want. Okay, we're back to being correct. Interval.min minus space.min. This is the amount we are shifting it. Oh, and we're shifting here by a negative. Okay, because we're shifting left. So this should be the opposite here. Oh, good morning, Marcus. Ready for your first coffee. Alrighty. I'm going through my to-dos and adding stuff to my mini library. Yeah, so in this particular example, I did this shift, which is basically copying the interval, but moving its start and end position. And now I thought that's useful enough. I'll just add it to the library. And while I'm at that, I might do like You know how my area has an expand function that gives you a larger area? I might do that for the interval as well. I can see that being useful. And there is a lot of cleanup to do in just this day 9. Maybe I'll do a little bit of cleanup here while I'm at it. Um, Back to point. Let's add an expand. So def expand. Again, this is an n and gives us another interval. I'm going to turn Copilot back on. Min minus n and max plus n. Okay. That should come in handy. And yeah, a better refractor. So I do these two sets of parsing to get the list of occupied intervals and the free space. I think I should just do that in one go. So if I were to do input that's sliding, and then after we get all the intervals, we can then assign it to either occupied or free by just alternating. So interval that's sliding window of size 2. Val all intervals. What's this gonna be? Let's say it's a list of interval of int. Okay. Now we have little strings. And we're going to do this car as digit. Now, when I was doing this, I think I had to keep track of some extra state, right? Because I was building this, but I had to keep track of where the index started. All this nonsense can disappear. So this can just be dot map. So case, there's a string, and we don't need to case that. S, now interval S0 as digit until, yeah, that's the idea. I think let's just take it down a bit, piece by piece. So, well, start. Oh, you know what? I do have to keep track of the index. Don't I? Yeah. Okay. This still has to be a fold left. Okay. So fold left. So we're keeping track of the index and list of empty intervals. Same deal. So this is going to be the size. Wait, I don't even need to look at 2 anymore. Okay, I'm being silly. I don't need to do a sliding of 2. We just map. So input. And we just go straight to the fold left. Okay. So we have our state, which is an index, and the intervals we collected so far. And then we have a new character. And val, so the interval size is going to be the character as digit. And then we do the new index, yeah, and then the new interval, or rather we can just do our new state is this new index onto interval, index until new index, sure. Yeah, I was thinking about index plus size here, but that actually, that works. Okay, and again, we take the underscore 2, then reverse. Head on an empty range. Wait, where are we doing something that could be head? Oh, probably this. There might be zeros in here. Um, Input, let's see, does this contain a zero? It does contain a zero. Okay, and that zero only really happened. So I think it's kind of, zero is hard to handle here because it's hard. I don't think it'll appear in part of the input. It doesn't make space, it doesn't make sense for like an occupied area to be zero, right? And then have two empty blocks next to each other. So let's do input dot sliding. Sliding 1, step is 2. And same idea here, but we're going to do a drop 1. So one of those. Oh, they're both false. Why? Let's just do a make string on this. And let's just test it with this actually, just to make sure it looks good. So 2, 3, 1, 3, 2. Yeah. We do the same thing, drop 1. Okay, that makes sense. The A10 hype. We are almost halfway. AOC is about to start getting real. Okay, so if the size is 0, we don't add. Yeah, I forgot that my interval type doesn't handle empty ranges, which is kind of silly. I should be able to do that. Okay, there's another to do here. To do represent an empty range. Yeah. I mean, how did my thing? Okay, free block size. Free block size could be 0. Okay, so we're gonna wrap this into options then. Option dot when size is greater than 0. Then we do this. So, I mean, this will get us all intervals, but option of interval. And then we're gonna have to flatten that down afterwards. Oh, hold on. Oh, Hellhound, thank you for the follow. and welcome, welcome. Wonder if we can get anything particular fun due to being day 10 of year 10. I don't know. That would be fun. I would really like to be part of the 500 star club at the end of this season, but that's not going to happen. I'm going to make that my goal before next season starts. I'll be going into 2025 as a 500 star person. I think this will be a nice refactor eventually, but I might go and check some of my other to-dos because um, well, they might come in handy. How many are still missing? What do you mean? So we're going to grab for 2024 and then grab worksheet. And then what are we looking for? Any kind of to-do. Day 8, add to math library. Oh, okay, I don't really have a math library, do we? Hmm. Okay, let's create a new file. We'll call this math. Oh, you know what? We should create a whole new directory. So AOC math package Scala. And I'm pretty sure I had other to-dos. Oh, is it stream stuttering for you? Hmm. Yeah, that is on my end. Let me debug that a little bit. Thank you for letting me know. Okay, so that seems to be in the last few minutes. I think we're just having temporary Wi-Fi issues. It is a winter. It is snowing outside, and the service isn't great here during the winter. Yeah, I'm setting my ground for today's challenge. Okay, I'm just gonna monitor that for a bit. Maybe I'll do a speed test in cellular, and if necessary, I'll move to cellular. I have a good data plan just for things like this. Okay, so day 8, 2024 headed to do. Yeah, GCF, I'll just add that. And you know what? Let's add some other stuff from my Project Euler library. Rain 6 degrees there in Germany. What is it right now? It is -3 here. And we've had snow on the ground for nearly 2 weeks now. 6-minute warning. Thank you. I appreciate it. Okay, primes. I don't need the primes necessarily, but these could be useful. So LCM and these LCMs are determined. This is in terms of an arbitrary integral. What is LCM n? Why do I have two? Oh, right. This is for multiple arguments. Okay, cool. I wonder if I could implement those two as just one function. Like this should be sufficient. Right, in theory, this would work with just two arguments. But I'll rethink that. Maybe I'll leave it to do just one function. I don't know if I need that variadic variation. Okay, let's add this to my AOC code. And what else? I don't know if I need to do the prime stuff. I kind of doubt we'll do any prime problems. Factorial might come in handy. Okay. Primes, Seaborn Aristophanes. Okay. It's good enough. We have a little math library. Oh, hold up, hold up. We are missing some syntax there. We need these. Okay. And I know there are more to-dos in here somewhere. So I was messing with my line class. I think this just needs to be tested. Ping, ping. Snow, rain. It's hot in Brazil. Hot summer in the Southern Hemisphere. 10 seconds? No way. No way. Unless both my clocks are... Okay, are you trolling? My clocks say I have 4 minutes. Oh, hold on, hold on. Yeah, there's time. Oh, hold up. You're saying the ping takes 10 seconds. Like you have a delay, like a 10-second delay. I see. It does say my stream health is back up on both YouTube and Twitch. Yeah, by the way, I'm also on YouTube. So that's an alternative. YouTube is on a slight delay, but it's better quality video and there's no background music. So if you prefer that, I'm there too. Okay, so my alarm's about to go off. I don't think I have time to test this, but I'll keep it bookmarked. I want to have a diagonal line be able to say if a point is contained. And this size implementation, I wasn't completely sure about. So I will test that. To test this. Both of these, both of the new stuff. You know, I haven't been thinking about the Avena code image. The music is lo-filia, by the way. Just video game music made lo-fi. Easy to digest in the background. And at this point, I associate with Avena code. I listen to this almost no time else. Okay, are there problems in here? Value plus is not membered. And did we remove some imports? That's not good. Okay, well, we can't fix that right now. So day 10. Oh, no, what am I doing? Day 10, 2024. Scale full screen. We have 30 seconds. Okay, surely that still works, right? Okay, my imports still work. I'm happy. Oh, good luck, everyone. Good luck. 10 seconds to day 10 of the 10th year. What do we have? Lava production facility. Let's get to the question. What is the sum of the scores of all trailheads on your topographic map? Ooh, we've got a map. Cool, cool, cool. Okay, so trailheads. How do you determine a trailhead? A trailhead is any position that starts one or more hiking trails. And a hiking trail is any path that starts at height 0 and ends at height 9. Okay, we get to do some Dijkstra today. And what do we call this? Trail topographic map. Okay, so we're gonna want area point. Val area. So let's take a look at this. Input. Okay, anything that starts with 0 and ends with a 9. And what are the rules for climbing? Okay, it shows from 0 to 9 as long as possible and has an even gradual uphill slope. This means it starts at 0, ends at 9, and always increases by a height of exactly 1 at each step. Okay, so it can only be 9 long. Up, down, left, right. You look up on the map, blah, 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 blah. Even gradual uphill slope. So can you go down and back up, or is it just always exactly 1 up every time? Okay, this trailhead has a score 4 because every 9 is reachable via a hiking trail except the one immediately to the left of the trailhead. Trailhead starts 1 or more hiking trails. The hiking trail is 0 through 9. The trailhead score is the number of 9-point positions reachable from the trailhead. Okay. Contains 2 trailheads. One starts here. The trailhead at top has a score of 1 because it only 4, 5, 6, 7. It only hits this one. But this one has a score of 2. Okay. This large example has 9 trailheads. Okay. I'm going to copy paste one of my Dijkstra implementation. So You don't need to grab 2024, just any worksheet with a Q. I'm going to put this in the terminal actually, so that I actually have space. Okay, 2023, day 20 is a good example. Day 20, 2023. You're done? You're done already? I haven't even started yet. I spent 3 minutes just reading it. Damn, dude. Okay. Are you done with both parts? Oh, wait, this is an actual queue. We want a priority queue. Okay, day 17. All right. This is my usual approach. I have a search function here. And we don't need state and whatnot. So here we're just doing positions really. So point to a list of points. And that would be like our climb function. So def climb from peak point to list of points. I'm not sure about that implementation. I don't trust that. Okay, and we start, at any of the starting points. This isn't really a Dijkstra, is it? No, this is just search through any, okay, forget this. I'm gonna comp this out for now. Let's start at the beginning. Let's find all of the trailheads. Now, trailheads equals points iterator. So top map P, we don't need to do this area.contains. So we just check that topo map equals 0. Okay. And for a given trailhead, we find number of trails, we count the number of trails. And then the score, how do we calculate a score? Score. The score is the number of 9 height positions reachable. Okay, so def find trails from some point, or let's just go straight up to scoring. So this is going to be int and def climb. So given a point, we get a list of points. So we take the adjacents, p dot adjacent, not adjacents. And then we filter that it's inbounds. And then we also filter not that, a topo map of this new area -1 equals h. Or rather, let's say it this way, h plus 1 equals topo map of this new area. Okay, And I guess we just to-list that. Mhm. So we climb until we find a 9, and if we not yet have a 9. Yeah, this is, I don't know why I started doing Dijkstra. This isn't a Dijkstra because we're not searching any kind of minimum. I'm being silly on autopilot. We just find all of them. We can just depth first search this. So score can be recursive. So if it's already, you take the height. If height is at 9, then the score is 1. Right? Yeah. Otherwise we get the sum of the scores in the adjacent areas. So P dot adjacent dot no, we climb from P. So climb from P dot map score dot sum. Okay. Val ends 1 equals trailheads dot map score dot max. Right? Is that what we want? 44. What is the sum of scores of all the trailheads? Oh, wait, we did want some. Okay. 1722. I have to wait 45 seconds, but I feel pretty sure I got it. I should just written this down from the start. I took a little detour searching for this Dijkstra code that I don't need. And you got part 2. Great, good job. Okay, can I submit now? 20 seconds to wait. Okay, I can start thinking about what part 2 could be. Coffee worked, great. 3 seconds. 1, 2, 3, go. And it's not the right answer. Okay, let's test on the example. I should have already been downloading the example. Okay, day 10, dot text 2024. So say this as dash example. And now we test on that. So we got 81, it should be 36. Larger example has 9 trailheads. So let's check that. So trailheads, that's size. We're gonna have more zeros. Oh, okay. 9 trailheads, sure. And for each of those, we only ever return a 1 once we've hit 9. Yeah, and we only hit 9 by climbing. So these like end early. Right, this is a recursive search down there. Am I having duplicates? So the problem with my score method is it doesn't tell me exactly where I'm going. I could print each. And does this function as a depth first? This would function as a depth first. Let's do this. Print line. Let's take spaces times height for an indent times h plus p.toString. Okay, this should be a nice little visualization. Oh wait, why is it so long? Why is it so indented? Oh, hold on. Ugh, these are characters. These are not. Okay. So my height function, it's not tuple map p. So def height p point. Nope. So tuple map p, that gives us a character as digit. Okay. We're gonna replace all of these with height. Okay, there we go. There we go. That should fix it. So, well, now we don't get any trailheads. Let's see what we're printing. 2021. So these are all my trails from each trailhead. Am I missing something? Okay, let's just check a height of a specific area. So height of 0.00 should be 8. Yeah. Okay. And 2 across and 0 should be 0. Right? Okay, that's working. That's working. Yeah. Let's try climbing from this point. Climb from 0.20. Okay, yeah, we go to 30, further to the right, and we go lower. So that's these two. Okay, I'm happy enough with climb. I'm happy enough with height. Uh, okay, let's take a single trailhead. Well, it seems like they're all ending up at 0. So let's just search one and see the result. So let's score. Trailheads ahead. So from 20, this has a okay. So 2021, 3, 4, 5, 6, 7, 8, 9, 4, 4. I'm gonna print the actual height afterwards. So plus. Okay, let's take a look at this again. So we're scoring this. We're at height 0, and we do hit height 9 at 4, 3, and we hit height 9 at 4, 5 as well. Okay, so 4, 4 is an 8, and it's not surrounded by 3 9s, is it? 0, 1, 2, 3, 4. Yeah, it is surrounded by 3 9s, so that should have a score of 3. Okay, let's do the score of 4, 4. And this should have a score of 3. Hold up, hold up. Yeah. Now the height is just 9. Oh, hold up. This is what happened. It's still 9 digits, or 9 character. Friggin' digits and characters. That's what's gotten me this whole time today. Okay. So now I'm seeing 81 again. but the score of this trailhead is 3. So that's good, right? The score of this one is 20. Why is the score of this one 20? Does it branch out in other places? So it branches out to a different 6. 7, 8, 9. Okay, yeah. And that 8 branches out. Okay, it gets to that 9 in 2 different ways. Cool. I see that on the map. And it branches from the 4 as well. Okay, I mean, I believe that has a score of 20. That's so high. I feel like I should have this by now. I did spend a lot of time not realizing I had some digit character mix up. So much for type systems. Okay, let's just check the score at the end. So let's see, when we climb from this 8, so the height of this 4, 4 is going to be 8. And when we climb from there, zombie shoe rating or show. Oh, you're already done with part 2 too. This feels easy. I should be done myself. Okay, so let's see. Score point. I'm just testing my stuff, looking for a bug. 4 or 5. So the height of this place is 9, so it should give back a score of 1. Yeah. Okay. Maybe testing one of these smaller examples. Oh, you know what? Let's do this. Let's get the scores of the individual trailheads and compare with what they had there. So trailheads.map score for each print line. So the individual scores. Oh, let's get rid of our tracing code. Or rather, it's just to list. It's not to list. Okay. 5, 8, 5, 4, 1, 4, 10, 24, 20. Okay, some of those numbers are way too big. Okay, simpler example. Let's just try this one. You are streaming and watching at the same time. He knows I'm safe. I'm not going to spoil it for you. Midnight Simon, what's up? Oh my god, a raid from Midnight Simon with 39 viewers. Welcome. It has been a while, maybe a year. So I'm still in part 1. It's easy, right? This is an easy problem. But I messed up somewhere and I'm debugging. So this is a good time for me to sit back and look through what I've done so far and maybe find where my mistake is. So I find all our trailheads. Everywhere we're starting at 0. I find 9 trailheads in the example, so I feel like that's accurate. Okay, I have a height function. This was a bug for a second. I was working with, I was mixing up characters and digits. So we get our height by parsing the character. And to climb, we check our height and we check everything adjacent. And we check those heights and we check that our height plus 1 is equal to one of those heights. Right, so our climbing function seems to work, right? Like in this example, we climb from the 8 down here to the 3 adjacent 9s. So I think my climb function is working. I'm pretty sure my height function is working. The score is really the meat of it. When height is equal to 9, it's 1. So this is like a recursive depth first search. And basically we climb from this current point, all the valid adjacent bits that are just 1 higher. And then we get the score of each of those recursively. And then sum. Maybe I'm missing something about trailheads. Even gradual uphill slope. They never include diagonal steps, right? Our adjacent only has up, down, left, right. Okay. 9 height positions reachable from the trailhead. Okay, and the above example. Okay, I'm gonna adjust my height function to handle these periods so I could try out some of these period examples. Well, no, C. If C dot is digit, then C dot as digit. Otherwise, what? Let's just say -1. Okay, and with that, we should be able to do another example. So let's open up save. Oh, we'll save this as day 10x2. Sure. And let's try this example here. So this has 2 trailheads, one of which has 2 points. So the answer here should be 13. Okay, let's look at our trailheads. So trailheads dot to list. We have a single point 3, 0. Is this correct? Oh, this trailhead has a score of 4 because every 9 is reachable via. Is it the number of distinct 9s? Or ways to end at a 9? Okay, the definition of score, let me check that real quick. The score is a number of 9 height positions reachable. Ah, okay. Okay. Okay, it's not the number of ways to get to the 9. It's the number of 9 height. Okay, well, I see the problem. Um, let's comment out this test code. So this score function now should track, I suppose. I mean, in this case, this is even dumber. In this case, we do a flood fill. We do a flood fill until we can't go anymore, and then we just count the number of 9s in that area. The last one. But I already have this approach, so I might adapt it. No, we're gonna search. So depth search. We're gonna have a visited set. And then a visiting And I think we're just going to return the very last set here. Yeah. Wait, let me think just a sec. Maybe I can very quickly modify this. If height equals 9, yeah, let's just modify this. We'll do the depth first search. Rather than score, we can comment out the old score implementation. Rather than score, we're going to do number of trails. So trail count, or, peak count, or rather peaks. So this is a set of point. So if height is equal to 9, then this is a peak. So return the set of this point position. Otherwise, we continue climbing, map peaks, and then reduce with union. Reduce all. Is reduce all a function? No. You're gonna fold left. So set.empty. Yeah, exactly that. Set.empty point with union. Okay. And def score equals peaks from that point. Dot size. Okay. So this should work for the example now, 36. Now let's do it for here. Misunderstood the problem, 786. Watch part 2 be what I solved originally in part 1. Okay. A second way to measure its rating, the number of distinct hiking trails which begin at that trailhead. I was solving part 2 for, oh my god, yes. I'd already solved part 2. I solved it first. How do we, I'm just gonna uncomment my old score. Whoops. Quickly, and then we're gonna comment out this score. 1722. I solved part 2 first. Ah! Okay. This is not the first time I've solved part 2 before solving part 1. Oh my god. Okay. Whatever. It was still a fun problem. They could, I don't know. I missed my chance for a 15-minute day. Yeah, I imagine there were a few of us that solved part 2 first. Reading comprehension. You watch those videos of the pros, like reading through, picking out whatever. I don't know how. I don't know how people read and understand correctly so fast. When I try to read and understand it that quickly, like this happens. I guess you have to make enough mistakes doing that as you're reading it, you're like, oh, wait, there could be 2 interpretations. Maybe I'm making a mistake. And you like correct yourself as you're doing that. Okay, I'm just going to redefine this as score 2. So we'll call this score 1. And peaks, climb, height, trailhead, shore. I think this is probably all more concise as like a flood fill instead of a recursive depth first search. But No, no, no. The flood fill would only really be nice for part one, not for part two. So I'm glad I didn't. I'm glad I didn't like nix everything and go do a flood fill approach. So ands one, use a score one. Ands two, use a score two. It's funny because I thought I was talking about myself, and then I saw Stu had the same wrong answer I did. Oh, and you were happy to sit and watch me do that. It's a skill set that also adds a bit to the error bars of the solving process for sure. Yeah. Okay. Well, I think from here, I want to finish what I was doing before I started this, which was sprucing up my little helper library. Score one, man. Score one. Okay, we do that cursively. Did I mix them up again? Okay, you know what? I mixed them up again. I'm just gonna leave that in the committed code as for the memories. Okay, we're at day 10. Okay, we're small 2024, day 10. Let's go back to, you know what? Let's check leaderboards real quick. I'm sure so many people solved this so fast. I'm like up in the 5,000s easy. Pretty close. Well, we got a break. I feel like this happens around day 10-ish every year where all of a sudden we have an easy problem again. And I think it might be intentional. You know, like prevent people from burning out on Avna code. Like, oh, they keep getting harder and harder. Like, we'll listen to a false sense of security before day 16 comes out and we're all spending all-nighters, right? That was fun. That was, you know, as frustrating as it was to be stuck debugging, the debugging process was actually kind of fun. I wasn't like sitting there scratching my head for too long. Okay, point. This is my little mini library. I have points, lines, areas, and a thing called an interval, which is like it's like a range, except you can treat it like a set, intersect, union, etc. Oh, Blue, did you do the same thing? Yeah, this year does feel like it's been easy. I had it really quick with snippets, despite and keep solution. Um, yeah, pretty small input. Right, like they could have made this. I don't know. I mean, the fact that you're only ever going 9 deep for one, and that you're like constrained to the grid branching at most 3, it could never get too hairy, the recursive search. Um, so a bunch of errors started showing up in here. I think I deleted an import. Let's see what we're saying. Integral is not a member of AOC.math. Oh, hold on. I see. We created a new package called math. This is part of Scala.math. Okay. Now, where were we? We're going to test some stuff. So this is, we introduced new syntax. I don't need to text that. Direction, vertical, horizontal. I don't think that needs testing. This size might need testing. So where are our line tests? We have no line tests at all, actually. Let's just put it after all the area tests and the interval tests. So I'm going kind of all in on worksheets here. I'm going to use my worksheets for testing as well, instead of using like a normal test suite. So let's say we take a line from 0.00 to, oh, not there. Let's say 0.02. Now the line should include both of those. That should be inclusive, right? So the size of that should be 3. Dot size equals 3. False. What is the actual size? Yeah, actual size is 2. Yeah, that was what was getting at me. So to calculate the size, if it's horizontal or vertical, then we get the absolute value of the delta. I could also just take like x range dot size. You know, I like the symmetry of that. If horizontal, then x range dot size. Else, if vertical, then y range dot size. Okay, that should fix things. Cool, cool. Yeah, that just takes the math out of it. Or, I don't know, kicks it off somewhere else. Otherwise, it should be dx.abs plus 1. Or either x range dot size or y range dot size. So this else case is diagonal, by the way. Okay, and then check if the line contains a point. So this line here should contain 0, 0, as well as 0.02. Okay, and let's just make sure it doesn't contain 0.3. You think it'd be solved in 38 seconds without an LLM? I mean, let me think. If you knew instantly, let me see what had to happen. If you knew instantly what the problem was, right? Like you scanned and you took a wild guess and you're like, okay, let's search the number of nines that can be reached from any given 0. Then you might start writing. So peaks, you might start writing this. How fast could I do this? I mean, this probably isn't a way you would write it if you're writing it that quickly. If 9, set 9, you have to climb. So basically get all the adjacent. You probably had that in your library, a way to get all the adjacent and check that it's in bounds, right? That's all that does. And then recursive search, fold left union, whatever your equivalent of taking the union of all the sets is. Maybe just like concatenate all of those. So map, concatenate, whatever your collections are. Like you could write this in 30 seconds. Like climb isn't really anything. Climb, this is really the only thing in climb that I had to write. The rest of this is basically should be library code. Right, so I do adjacent, which is library code. I additionally add this inbounds check, which honestly, that inbounds check should be part of my library code too, if I have some grid class. And this isn't the first time you've climbed one unit at a time. So And you know what? Oh, I think I know what I was thinking. I was thinking with the characters and digits, you don't need to parse this as a digit. With the characters, you can just check, if one character comes after the other, they're all going to be in a row anyway. And I think somewhere I wrote an actual digit, and then that's what screwed me up. And I decided to go back and change all the characters to digits as well. So like this code didn't need to be written. I don't know. If I knew what was going on and I had to write this all, it would still take me a couple minutes. Just makes me think someone could do this in 30 seconds. But then you have to parse the problem in 9 seconds. So it kind of screams LLM, doesn't it? Um, okay, so my line that contains, that's cool. I don't know. For diagonal, I'm just gonna leave that unimplemented for now. I don't think that will come in as handy. I mean, but if it did, we would do, we would check, I guess we could use a dx and a dy. Q minus p. If it's some multiple of the dx and the dy. Yeah, so we can look at the difference. So r minus p, so the difference between r and p. So this is like, this is also a point, but this also serves as like a delta vector. So the x should equal the y dot x equals r minus p dot y. I think that's how you would check if your point was contained on a diagonal line. The first 10 ranks are LLMs. I believe it. Yeah, Hyper Neutrino talked about on Reddit. I haven't seen the Reddit posts, but I am in their Discord, and I've seen some posts about the LLM problem that we have this year. No clue. Yeah, next time Eric Wassell's in here, I want to ask what to do about the LLMs. I mean, so far, as far as I can tell, he's tried to like asking nicely, but maybe like a verification process. That's like time intensive. I'm gonna test the diagonal line. So line. So let's go from something kind of random. So like 3, 4, 2, 5, 6. So that's the diagonal line. And let's test what contains. That should contain 45.45. I guess I can make that an assert. And then let's make a few modifications. It should not contain 4.4.55, right? Okay, those asserts all passed, so I'm happy with the diagonal implementation. Cloud O1 can solve this in no time. Yeah, I mean, okay. Like this one's so easy. If you're using an LLM, then why did it take you 38 seconds to copy paste? Is that what you're saying? Couldn't you do it in 5 seconds? Hmm. Okay. Here's a big one I really want to mess with. So this interval class, I just created a shift and expand so I can move my intervals around. Um, I will want to test those. I still don't know what to do about empty intervals. Like this can be an implementation, and then we could represent an empty interval with an object. Like what would it look like if it's doing the same interface? Well, actually, it's still going to be a class because it's going to have the n. Maybe this takes some offline thinking. I might have written myself into a corner by having a min and max. But I do still have other things to fix. If you check the repos people, you can see the prompt. I think no human can solve in 16 seconds. I'd be inclined to agree. Um, okay, we'll figure out an empty interval at some point. Shift and expand. Let's test those. So interval 0 to 2. And let's shift rights by 5. That should be interval 5 through 7. Okay. And let's expand by 1. Let's try expanding by -1. -1 should give us the interval 1 to 1. Yeah. And I know this here should error out 0 to 1. Expand by -1. Maybe it doesn't error out. Ooh. Should error. It shouldn't be possible to construct that. So I need to make sure my constructor is smart about that. Um, Interesting. So it just takes any two numbers. Oh, okay. Yeah. My interval, I probably had a good design reason in a particular problem for doing this. But it takes any two numbers and takes the min of one of those to another. How do we still end up with 1 to 0 though? Because we're using the copy constructor. We don't want to use the copy constructor. Okay. Um, Actually, I think the top one, it's safe to use a copy constructor, right? But for the bottom one, I do want to construct a new interval altogether. Okay. Now this turns into an interval 0 to 1 to do error 1 too small. I don't know what I want to do there yet. What I do want to do is get to bed soon. So I'll probably just note a few more to-dos. I still have to think about the empty interval problem. My area, I was able to get the edge lines of an area, and I think I can move an area already, right? Hmm. Verified leaderboards. Yeah, I mean that's just it's like a lot of work, right? I don't know how much of a budget they have. I know for the puzzles it's a one-man show. X minutes after your solution to provide an explanation to your solution. I'm not sure about providing an explanation. Have an LLM do the verification, or yeah, the LLM could just provide an explanation. Video proof is the most reliable, but that might be like an unnecessary burden on the users, right? You can't get on the leaderboard if you didn't have a video. Maybe not anyone on the leaderboard, but top 10 on the leaderboard. If you're going to be top 10 on the leaderboard, you expect to be a top 10 on the leaderboard, right? So you're already, you know, if you know that to be on top 10, it's a requirement that you have a screen recording. Maybe that's reasonable. Maybe that's reasonable to ask for like the 100 or so people that think they might be top 10. I mean, that is easier to verify, right? Like you check 10 videos. He could have one of his beta testers do that or something like that. Um, or maybe just post it publicly. Like this could be the labor. The labor goes to the people writing the solutions. I don't know. I kind of like the video solution. Um, I think we should find someone to raid. If you all know someone who's still online right now, I'll take suggestions. But before I do, I just want to check in on our leaderboards here. What happened? What happened? I'm sure I got eaten up today. For day 10, 13, 12. Honestly, I was prepared to see like 20 in here. Um, but in our little leaderboard, we have we have like 3 people here with global points. Still taking 4 minutes for the first part, 8 minutes for the second part. Okay, but he's short by delta. I'll take that win. Took me 45 seconds to uncomment my solution. And I saw it coming too. Didn't I say that as I was loading? I was like, oh, I'm gonna have solved this already. um, let's see. If you'd like to join, here is my leaderboard code. Yeah. Today was still really fun. Bront TV. I've never heard of Bront TV. Let's take a look. Still working on it in Kotlin. Okay, I don't see a lot of Kotlin. I've used it a little bit. I would kind of like to watch some Kotlin. So why don't we raid Ront TV and see what they're up to? All right. Well, good night, everyone. GG. Thanks for stopping by and commiserating about solving the wrong problem. A few of you that did the same thing. And we'll see you all tomorrow. Oh,